So here's another example. So it was found in a study that about 65% of 10-year-olds are afraid of spiders. So can the CLT for proportions be used with n equals 25? And then what about n equals 30? Okay, so that's the first problem. So first let's start off with n equals 25. So when n equals 25, let's try to figure it out. We need to check that np is greater than or equal to 10. Okay, so n in this case is equal to 25. P is equal to 0.65 because that's the percent that's afraid of spiders. Okay, I multiply this out and I get 16.25, which checks out because this is actually clearly greater than or equal to 10. So that's good. Okay, but however, we also have to check that n 1 minus p is also greater than or equal to 10. So I'm going to have 25 times 1 minus 0.65. So when I put this into my calculator, I'm going to get 8.75. This is not greater than or equal to 10. So this one, we cannot use it. Cannot be used because it's not satisfied. Okay? So these, for n equals 25, unfortunately, we cannot be able to do it. Okay? It's not large enough. What about when n equals 30? Well, when n equals 30, we got to do it again. np has to be greater than or equal to 10. So I'm going to take 30 times 0.65, multiply this guy out, and I get 19.5, which is greater than or equal to 10. So this is good. Okay? Now what we got to do is figure out that n1 minus p also has to be greater than or equal to 10. So 30 times 1 minus 0.65. I put this into my calculator and I get 10.5. So it barely made it. Okay, so it just barely made it, which is still good. So this one, yes, it can be used. Just by a little bit. Okay. All right. So now what we're going to do, so that's all you want to do for part A. Now in part B, we want to write out the sampling distribution when n equals 30. Okay, so we already know that when n equals 30, this is able to be done. So now all we got to do is figure out what the mean is. This guy is going to be the mean of p hat. And this guy right here is going to be the standard deviation of p hat. Okay, so let's figure out what that is. So the mean of p hat is just equal to p. P in this case was just equal to 0.65. So that was easy, 0.65. And now we need to figure out the standard deviation of p hat. That's just going to be equal to square root p1 minus p over n. So we're going to have 0.65, 1 minus 0.65 divided by n, and in this case is equal to 30. Okay, I'm going to put this into my calculator and I'm going to get 0.09. So 0.09 is going to go in there. Okay, so there's my sampling distribution. And finally, all we really want to be able to do is do part C. This is the last question. Okay, so find the probability that at least 70% of the 30 10-year-olds are afraid of spiders. Okay, so from the 30 10-year-old people that, or 10-year-old kids that we sampled, what's the probability that at least 70% of them are afraid? Okay, so this is just a regular probability, normal probability problem. So we know that it's normal. My mean in this case is 0.65 because that's what the normal, my sampling distribution said. Now we want 70%. 70 is around here, 0.7. And then we want everything that's at least means greater than. So at least is all of this guy. And we know positive infinity is over here. So all we have to do is just use normal CDF. It's going to be norm CDF. My lower bound in this case is going to be 0.7. My upper bound is going to be equal to infinity. My mean is equal to 0.65. And my sigma, which is my standard deviation, what was it again? 0.09. Okay, so in my calculator, let me go ahead and... So I got normal CDF, lower bound, 0.65, 0.09, 0.7 to infinity. I got 0.2893. Okay, that's what I got. Okay, so so that was another example of the central limit theorem. It's exactly the same thing. If you can see, the only thing that really changes is the sigma, right? The sigma is the one that really is changing because you have this other square root of that. So it's very similar to normal. And you'll see that when we talk about central limit theorem for means, the sigma is basically the only one that really changes.